Hey guys, welcome to June.
You did it! Congratulations!
And Unit 10, you have 4 lessons this week, and that is it. You will get one Google form at the end. That'll be a wrap up for the whole year.
I'm so excited, and I just can't hide it.
So almost through. I'm going to pre-apologize. This is a long lesson. I'm going to talk fast, and it's long because there's a lot of slides, but the slides don't require a lot of work. So Unit 10 is all on solids, 3-dimensional figures, cylinders, cones, pyramids. You guys should have done this earlier in life, but this is a good review, okay? So today we're going to just identify the difference between them, know their names.
What's my name? What's my name?
We're going to say, okay, what if I take a 2-dimensional image like a piece of paper and I rotate it? What happens? Like I'd form a cylinder. And then we're going to look at what a cross section is. So kind of like a fruit ninja. Okay, those of you artsy people that can visualize stuff, this is going to be your thing. Some of us might have to take actual shapes around us and help us through. All right, so I'm going to talk fast and move. You guys know the deal. Make sure you complete the homework. Okay, it's due by Sunday. So let's look here, some vocab. First off, when you have a 3-dimensional image, when I say these words, you have to know what they mean. So the base is like the top and bottom. Okay, so that's a base and that's a base there. They are typically congruent to each other. If you have a prism or a cylinder, we'll learn those words in a minute. They'll be congruent and parallel to each other. So same size and parallel. The edge, you guys get that. That's just like where there's a fold. So like that would be an edge. Vertex is anywhere you see a point. So that's a vertex, and that's a vertex, and that's a vertex. Fun. Lateral, anytime you see something lateral face, lateral goes around the sides, just like your lateral muscles, right? So the lateral faces, this shape here, this is a prism, a rectangular prism over here that I'm drawing on. This has 4 lateral faces. So 1, 2, 3 is the back, and 4 around the side. So that has 2 bases, top and bottom, 4 lateral faces, okay? A polygon is just a shape that has sides, okay? They're not circular, so we're going to say not rounded sides, okay? And a regular polygon, anytime you guys see the word regular, you know that it means equilateral. So it's a polygon that is equilateral and equiangular. So an equilateral triangle is regular. A square is regular. Okay. So here you have 4 different types of 3-dimensional shapes, and you need to know the difference between them. How do I look and know what a prism is? So here's a prism. These are all examples of different types of prisms. You have a triangular prism, a rectangular prism, a pentagonal prism. You will see that a prism is named from its base shape. So this first one, the triangle prism, it's called a triangular prism because the bases, the 2 here and here, the 2 that are congruent and parallel, are triangles, okay? So a prism is a 3-dimensional solid that has polygon bases. So it's going to have, it's not circular, so not a cylinder, right? So the bases are going to be both congruent and parallel to each other. So if it's a prism, it's got a top and a bottom that are congruent parallel. This rectangular prism, it's called a rectangular prism because, again, the top and the bottom are both rectangles. They're congruent to each other. They are parallel. This is a pentagonal prism because the top and the bottom are pentagons, okay? It's actually the only 2 pentagons there. What are the faces of this pentagonal prism? Well, the faces, the lateral sides here are rectangles, okay? So there's 5 faces, there's 5 rectangles, and then a pentagon and a pentagon that are congruent and parallel to each other, okay? So that's a prism polygon base. A cube is another type of prism. It just has squares. So this is the only one that all 6 sides are congruent to each other and all 6 sides are squares. Types of prisms. So you can see what we call a right prism. In here, we think of right, like right angle. You should think of it that way. So it's just a prism that the sides are completely straight or they're perpendicular to the base. So you can see like this and this, they're perpendicular. They form a right angle. Oblique just means that it's tilted some. So anytime you see oblique, you're going to think that it's just kind of tilted. So again, clearly this side and this is not a right angle. So that's what oblique means. So here, if I wanted to label these as right or oblique, and then name them each, well, this here is a prism. The top and bottom are congruent. There's 1, 2, 3, 4, 5, 6 sides. So these both are hexagonal prisms, hexagonal, because a hexagon has 6 sides. Again, 1, 2, 3, 4, 5, 6. Okay, they're both hexagons. They're prisms because the top and bottom are congruent and parallel to each other. Okay, and this first one here, this is right because it stands up straight, and this guy here is oblique because it looks like somebody just went boop and it tilted some. Okay, so that's a prism. Prism, polygon base, top and bottom are congruent. God bless you. Cylinder, like circle. A cylinder, like a Pepsi can, right, is a three-dimensional figure where the bases, the top and bottom, are circular or rounded. Okay, so if you look at these two here, these are both cylinders. So this here is your typical cylinder because the top and bottom are circles. Okay, and then the inside is, it doesn't have like polygons, it doesn't have hard sides. It just kind of goes all the way around too. Actually, if you open that up, it'd be a rectangle. This one here, this funky shape here, that doesn't even have a name really, baseball field, I guess. That's a cylinder as well because this shape is not a polygon here. It's got that circular side to it. So that's a cylinder. For a cylinder, the bases are not only circular, but they are also congruent and parallel to each other. So this top and bottom circle here are the exact same size. It's like a cylinder. A perfect example is if I stacked a bunch of quarters. All quarters are the same size. It's a cylinder because the top and bottom are congruent, and it's uniform, or it's the same all the way through. Okay, just like with prisms, with cylinders, you can have a right cylinder and an oblique. A right cylinder is where the edges here, they are perpendicular to the bottom. Okay, so it's standing up straight. Think of it that way. Oblique just looks like it went, it's just tilted a little bit. So that's all you have to know for oblique. So just understanding what we've done so far, a prism has a polygon base. So it's a shape with like hard sides. A cylinder has a circular base. Right means it's perpendicular sides to the base, and oblique just means it's tilted. So quick review. A cylinder, so a general cylinder, they kind of classify all these as cylinders, which I don't like that. But if it has a polygon base, we're going to say it's a prism polygon, PP. If it has a circular base, circular cylinder. If the edges are perpendicular, it's called right. If the edges are not perpendicular, it's called oblique. So far, so good? I hope so. So let's say, is this a cylinder? Well, it has circular bases, right? That's a circle and that's a circle. But what else is the requirement? To be a cylinder, the top and bottom have to be congruent and parallel. Although circles parallel? No. So this is not a circle because the top and bottom, or the bases, top and bottom bases, are not parallel. Sorry, terrible handwriting. You're used to it. Okay? So that was prisms, cylinders. Let's look at these, cones and pyramids. Well, first off, what's the biggest difference you see for both of them from what we just did? See, they go to a point. Okay, so cones, we're going to identify the similarities and the differences between a cone and a pyramid, and then how are they different from cylinders and prisms? Well, first off, a cone, and I'm actually, let's just list the properties here. Let's get rid of this. Okay, what does a cone have? It has a circular base. Circular base, right? A pyramid has a polygon base. What do they both do to, like, what's similar about a cone and a pyramid with each other? They both go to a point. So the top and bottom bases are not congruent. Actually, they don't even have a top. They go to a point. Okay, so let's look really quick. I think on the next page I have this. What's a similarity between a prism and pyramid? They both have polygon bases. Let's actually name what's a difference between them. Okay, a pyramid goes to a point. Okay, it meets at a point. It's like a triangle. Whereas a prism, the bases are congruent and parallel. So the top and bottom has to be identical. Let's list some information about cylinders and cones. So again, here's a cone here. That would be a cylinder. And I could draw it, okay? So what's one similarity? Well, they have circular bases, circle bases. The difference is, though, that a cone goes to a point. So essentially, like, instead of stacking quarters, like you're stacking smaller coins, right? So it gets smaller as it goes up, whereas a cylinder, again, the bases are congruent and parallel. Okay? So just to define that out, a pyramid has a polygon base, like we said, except this time it goes to a point. They're named just like a prism. So in this one, the bottom, it's a rectangular pyramid because the bottom here is a rectangle. And again, it goes to a point. Each of these, if I draw rectangles on the inside, these guys are there. They're just getting smaller as they go. This is a triangular pyramid because the bottom is a triangle. So it's named after that base. And you can see as you get closer to the top, the triangles are getting smaller. This is a hexagonal pyramid because the bottom is a hexagon. And again, you can see those hexagons are getting smaller as they go because they go up to a point. So a pyramid has a polygon base, but it goes to a point. Right, again, just means that it's going to be perpendicular. It's going to be straight up and down. Oblique, that center point is just going to be moved or tilted a little bit. All right. A cone, though, so again, that was a pyramid. Pyramid, polygon base goes to a point. Cone, circular base, also goes to a point. Okay, so these guys have circles. They just, unlike a cylinder again has a top and bottom that are congruent circles. These guys, as if I draw these circles in here, the circles are just getting smaller as I go. This funky shaped one, this is also a cone because this bottom shape is curved. It's circular in some way or shape, okay? A right cone, the point is directly above the middle of that circle or the center of that circle. Oblique just means the top point is tilted some. Okay, so let's group the following of these. I'm not going to write the names of them. See how they're labeled 1 through 8. So we're going to say which ones are cylinders and prisms. So let's look at all the cylinders. Cylinder has to have curved bases, top and bottom congruent. So number 1 is a cylinder. Number 2 is not a cylinder. What is it? It's a prism. Number 3 is not a cylinder or a prism. That's a cone. Number 4 is not a cylinder or a prism. For both a cylinder and prism, the top and bottom have to be congruent and parallel. So number 4 is a pyramid. Number 5, pyramid. Number 6, circular base. Their top and bottom are congruent. That's a cylinder. Number 7, top and bottom are congruent. Polygon base. That's a prism. Let's turn the page. Okay, so now on this page, instead of being prisms and cylinders, they asking for pyramids and cones. So pyramid goes to a point, pyramid, polygon bottom. Cone goes to a point, cone, circular bottom. All right, so number 3 is a cone because the bottom is circular and it goes to a point. Number 4 is a pyramid because it goes to a point and the bottom's a polygon. Number 5 is a pyramid because the bottom is a polygon and it goes to a point. Number 6, we already said, was a cylinder. 7 was a prism. 8, circular base goes to a point. That's a cone. So hopefully you understand the difference between them. Okay, so let's look at this one. Which 2 shapes could be used to make the pencil below? Well, in this one, think about it. You've got the point here. It goes to a point, right? And it's probably at this circular base. So what's that shape? That is going to be a cone. Circular bottom goes to a point. And then the other one, you've got this shape here that is also circular, but now the top and bottom are congruent, so that is a cylinder. So we're going to do choice 4. It's a cylinder and a cone. And I know you can argue that because if you look at the pencils that you can really see the ridges around, we could call it something else probably. But I'm going with cylinder and cone. What's the best name for this? Well, the top and bottom are congruent. They're circular, so they're definitely cylinders, right? But it's tilted a little bit, so it's oblique. Hey, erase for me. Here we go. All right, the next part here is what if I have a two-dimensional image and I want to rotate it to form a 3D image? So you can click on that link. Essentially, what we're going to do with those is it's going to show you a separate video on how if you take a 2D image and you rotate it, what three-dimensional image will it be? So this is where like you guys that are artsy and you can see stuff in your head.
Uh-oh, she's looking at us. What did she say? Oh, sorry, sir. No one was listening. Is it garbage night? We left the toilet seat up. What is it, woman? What?
You're gonna be really good at this. Some of us might have to actually take like a piece of paper and fold it to see what's gonna happen. So let's look at a couple of these problems, okay? So if you look here, this one says triangle ABC, this triangle here is gonna be rotated about line segment ED. So again, you're gonna imagine that it spins around. And if it spins around, can you see that first off the bottom is going to be circular and it's a triangle. So it's going to look like this, right? So it's going to spin around here. And actually AB is just the radius. So it's going to spin around and double. So that is going to be a circular bottom that goes to a point. That's a cone. I literally in my head, I'm like, all right, circular bottom, which two start with C, goes to a point, it's cone. In this one, it wants us to rotate this rectangle around that line. So if you visualize it, that rectangle goes around. Well, first off, when it goes around, it's going to get these circular bases, and the rectangle in between is going to form, right, this type of shape. So circular bases, it's either a cone or a cylinder. Which one is it? This one happens to be a cylinder because the top and bottom are congruent. Ooh, this is a little bit interesting. So this one wants us to take this circle here and rotate it over that line. Now see how it's not touching that line? So it would like rotate around, but it's gonna leave a space in there. So it's gonna look like a donut. My daughter was actually doing stuff like this for actually 7th grade. And she's like really artsy. So she was good at visualizing these. And I'm like, oh, let me think about it. So these sometimes, unfortunately, are just about like how you see things, okay? So that was taking a two-dimensional image and rotating it. Last part for today is what we call a cross-section. A cross-section is cutting a 3D shape and seeing what 2D shape is formed. So kind of the opposite of what we just did. We just took a 2D shape, we rotated it and made it into 3D. Now we're gonna take a 3D shape and say, okay, if I cut it in some way like Fruit Ninja, what shape am I left with, okay? So if you look here, here's some ideas of cross sections. Well, in A, these both have polygon bases and the top and bottom are congruent. So both of these are prisms. And if you look here, you can look at different cross sections. So this here is a cross section. Do you agree that that particular cross section is a triangle that is congruent to the top and bottom, right? Okay, same thing here. It looks like we have a rectangular prism. So this cross section here happens to be congruent as well. Now you won't always get a cross section that runs directly parallel to the bases. Sometimes if you look at this, you can get a cross section that's funkier. So this would be a circular cross section, but it's not going to be congruent to the top and bottom because of how you cut it. If you think of the game Fruit Ninja, none of us, at least I can't, I never cut it so it's straight across when I'm playing the game. It's like my cuts are all over the place, so I could be forming different shapes. So that's the idea today, is to look at these and say, okay, if I cut it in this way, what shape will I get? Well, look here. In C, this has a polygon base and it goes to a point, so this is a pyramid. Now this time, they cut the cross section like perpendicular to the base. It's definitely still a triangle. Can you see that here? But it's not going to be congruent to the bottom triangle, the base. Here, this is a 1, 2, 3, 4, 5. So that's a pentagonal pyramid because it goes to a point. This one, okay, the cross section looks like it's pretty much parallel. Now let me ask you, it's definitely a pentagon. Is it congruent to the bottom? No. Okay, so you're going to see that for this one, this again is a pyramid here. The cross section is the same shape because I cut it parallel, so it's the same shape, but it's not congruent. You'll see that it's similar, which we would have spent a lot more time of that in class, but that's okay. So there's two types of cross sections. The main type is a parallel one. So when you have a parallel cross section, you're going to see that it is the same shape, but not necessarily the same size. So if I cut a cross section through, it's going to be the same exact shape, but maybe not the same size. If you have a prism or a cylinder, the cross-section that is parallel will be congruent to the base as well. So if you look at all of these, you can see those cross-sections in there. The first one's like a square prism. The second one is a triangular prism, and then even a cylinder. You can see all of those cross-sections are congruent because a cylinder and a prism, the top and bottoms are congruent, so it stays the same all the way through. So if I cut parallel, all of those inside shapes will be exactly the same shape and the same size. Do you think the same is true for a pyramid? No. Or a cone? No. So again, why would the cross sections cut parallel to the bases of a prism or cylinder all be congruent? Well, because the cross sections don't change size. That's your answer. All right. So if you're given a cone or a pyramid, the cross sections cut parallel to the base will all be the same shape. Oops. But not the same size. They will be similar. Similar in size. Okay, so if you look here, this here, circular base goes to a point, is a cone. So if I cut a cross section, it's still a circular base, it's smaller. Okay, here again, this is a pyramid. It's got a polygonal base, it goes to a point. So this cross section here.
I didn't get that.
Oh.
Could you try?
Apparently Siri wanted to answer me. This cross section here is the same shape, but it gets smaller as it goes. Okay. So what's different about a cone, a pyramid, and a prism and a cylinder? Again, a cone and a pyramid, the cross sections change size for a cone or a pyramid because it gets smaller as it goes up. That's what we're going to write, because it goes to a point. So the closer you are to the top, the smaller your cross section is going to be. So notice the cross sections are getting smaller as you get closer to the top of the solid. It makes sense. Okay, so here's just some quick examples. In this first one, you have a pentagonal pyramid. You can see that that cross section in there is still a pentagon, but it's clearly smaller. You have a triangular prism. For this one, again, it's a prism. So it's the triangle has to be congruent. So this middle one in here is congruent to both the bottom and the top because it's a prism, which again, this one is a pyramid. So the pentagon has gotten smaller as it gets closer to the top. Same thing here. You have a cylinder and a cone. So the cylinder, this one, the cross section is the exact same size. It's congruent to the top and bottom circles. Whereas in the cone, clearly the cross section is smaller because it's getting smaller as it goes up top. Okay. When you have cross sections that are parallel to the base, it's way easier to see because you just, whatever the base shape is, it has to be the same shape. When you have a cross section that's not parallel, this is where it can get tricky. Okay, so look at these two. You have the same cylinder. First picture here, cross section is parallel. You get a nice little circle. Because of the cylinder, that circle is congruent to the top and bottom. If you cut it perpendicular, though, the cross section is no longer a circle. It's a rectangle. So you have to imagine like literally slicing it down, which I left all of my 3D shapes in my classroom. So you're just going to have to visualize or Google, okay? And you can see that that's going to be a rectangle, not a circle. So here's some more examples. Cylinders, you can go vertically, you can angle it so it's sliced funky. It can be horizontal or parallel to the base, so then it's the exact same shape. But look at this crazy shape going on here. I'm going to let you kind of digest all of that. That's got a ton of different cross sections. You can cut like little pieces out here and there. There's a video there if you want to go to, up to you. So here we have the intersection of a cylinder or a prism that's perpendicular. So if you look here, again, this is a cylinder. When it's perpendicular, it's not too bad. For a cylinder and a prism, because the top and bottom is the exact same shape, these cross sections are both rectangles. If you look here, a pyramid or a cone, again, if it's a perpendicular cross section, that's actually not too bad either because they go to a point. Your cross sections are always going to be triangles. Okay, a sphere like the globe, your cross section here is going to be a circle. Notice like the equator, the biggest circle is going to be in the middle. And for a sphere, as you get closer to either ends, you're going to get circles, but they're going to get smaller as you go further away from the middle because a sphere is just circular all the way around. Okay, again, you can also get these diagonal crazy cross sections. These are harder to visualize, but just to give you a kind of outlook, in a cylinder and a cone, you get these ellipses. They're still circular if you're just cutting through a piece. Okay, if you have these here, so we've got more cones, then you can get different shapes, all types of funky things according to where you cut it. So we've got cylinders and cones there. So you still get something with like a circular piece to it. It says, look at the picture and determine which cross-section is congruent. Well, the congruent one needs to be parallel. So that's this here, and that would be your explanation. That one is the congruent one because the cross-section is parallel. This one says, state whether the solid is a cylinder or a prism. Draw a sketch of the cross-section that's parallel to the base. Let's see how my sketches do. So this first one here, top and bottom are circular and congruent. So this is a cylinder. Cross-section parallel to the base would look just like it. This next one, the top and bottom are, there's my dog, are polygons, but they're congruent. Okay, so this is a prism. So the cross section, if I were to draw it in here, I'm going to draw it on the inside, would be a congruent pentagon. Pretend that's congruent. This one, top and bottom are congruent and they're polygons. So this is, well, a prism. The cross section here would be congruent to top and bottom. So it's like an L. Okay. This, the top and bottom are circular and congruent. So this is a cylinder. And the cross section parallel to the base would be a congruent cylinder. Okay. So if you look here, comparing cross sections of prism cylinders versus pyramids and cones. So this first one here, this is a prism. This is a pyramid. These both have polygon bases. Pyramid goes to a point. In A, it says if the cross sections are cut parallel to the bases were taken in each of the solids above, what similarities would the cross sections have? So similarities, if they're cut parallel to the base, the similarities are that they're the same shape. They're a five-sided shape, so they're both pentagons. What would the differences be? Well, for the pyramid, the cross sections, Corey, can you take the dog out, honey? Are not congruent. So they're not congruent. They get smaller. And for the prism, all of the cross sections to the base that are parallel to the base are congruent. Let's look here. Now these kind of, I have the pictures on the side that have the answers because it's hard to visualize. All right, it says a right cylinder is cut perpendicular to the base. The shape of the cross section is. So if you guys got this on the Regents, it would not have that picture, but since there's no Regents and this is tough to see and learn, and we're doing it really fast, we put them in. So if you look here, a right cylinder is cut perpendicular to the base. The shape of the cross section is, well, you can see, cut perpendicular to the base. This cross section here is a rectangle. I think my mailman's here is why my dogs are going crazy. In number 5, which of the following figure does not have a triangular cross section? So if you look here, in A, it's a square pyramid. So that's actually this yellow picture down here is a square pyramid. So that one you can see has a triangular cross section right there. B, a cone is this picture here. This is a cone, and you can see that it also has a triangular cross section. In C, it's a rectangular prism. That's a hard one to visualize, but if you like sliced off the piece here, you would get a triangle. So D, a cylinder, is the only one that does not have a triangular cross section. No way to make it because all the edges are circular and the top and bottom are congruent. Number 6, William is drawing pictures of cross sections of the right circular cone. Below, which drawing cannot be a cross section? So look. The answer is there. So if you see here, this one, if you have a cone, you can absolutely have a triangular cross section. So choice 2 is out. I went the one that cannot be. You can have this like parabola looking hyperbola thing. So choice 3 is also out. You can have a cross section that's an ellipse or an oval. So 4 is out. So the only one that cannot be a cross section of a cone is like a square. Okay, so the key thing, cross sections that are parallel to the bases of pyramids and cones are not congruent, but they are similar figures. So if I have, again, a cone or a pyramid, Those cross sections aren't the same size, but they're similar. And we learned about similarity and dilations this year, which means that you could probably set up a proportion and solve for missing sides, which we're going to have to do in a minute, and then it'll be it. Okay, so let's quickly review everything that we've done with cross sections. Cross sections of prisms and cylinders are congruent to the base shape. Okay, if the two are congruent, what do you think you could tell me about the area of the cross section? Well, it's going to be congruent to the area of the bases. So if I wanted you to find the area of a cross section, if you have a prism or a cylinder, you just find the area of the base shape, and then this is your answer because the cross sections are congruent. So this again only works for prisms and cylinders because they don't go to a point. It will not work for pyramids and cones. Let's look at some quick examples. Finding the area of the cross section of these. Well, again, this first one, it's a cylinder. So the area of the cross section is congruent to the area of the top and bottom. Area of a circle is pi r squared. So for that first one, if I want the area of the cross section, it's just pi times the radius. Well, the diameter here is 4 centimeters, so the radius is 2. So 2 squared, we're just going to leave that as 4 pi. In the one next to it, same idea. If I want the area of, Corey, can you let the dog back in, please? If I want the area of this circle, I'll do this one in red. Pi r squared. In this one, the radius of this, if the diameter is 8, the radius is 4. So you can just find the area of the top or bottom. It's congruent to the cross section. Area equals pi times 4 squared. And again, I'm just going to leave it in terms of pi. So the area of that cross section is 16 pi. Okay, let's look at the bottom one. So these are prisms. So for the area of the cross section, as long as it's parallel to the base, I just need to find the area of that triangle there. Okay, area for a triangle for that one is 1/2 base times height. So for this one, its area equals 1/2 of 5 times 12. 5 times 12 is 60. So the area of that is 60. Oh, 60 divided by 2, sorry. 60 divided by 2, so it's 30 centimeters squared. This area. I should have put the units above, sorry. In this one, this is a rectangular prism. So the area of the cross section is equal to the area of that rectangle. Area of a rectangle is length times width. So this one is 5 times 6. So this one also is 30. So it's 30 centimeters squared. Unfortunately, not so easy if you have a pyramid or a cone because the cross sections of a pyramid and cone are not congruent to each other, but the two are similar. So what can you tell me about their area? So do you remember? Area of similar figures is equal to the scale of the sides squared. Okay, so this is very quick, and I know that this is not easy, but you really shouldn't be bad at it, okay? So this says because the cross section is a similar figure to the base, you can set up a proportion and solve. In other words, side over side squared equals area over area because they're similar, and we're looking for area. So we did this before, just now we're doing it with 3-dimensional shapes, but when you cut a cross section, you're back down to a 2D shape, so you're okay. So if you look here, says we have a triangular pyramid. So that's why I know this cross section is not congruent to the bottom. Otherwise, I could just find the area of the bottom and call it a day, but I can't. It gets smaller as it goes. So if you look here, it says the area of triangle ABC. So the big guy has an area of 25 millimeters squared. It wants to know the area of the smaller one. Well, it shows me on the side here the scale factor. So the scale factor here, this whole length is 5. And this length is 3. So the scale factor, you can set up like 5 over 3 if you wanted to. So the ratio of the areas of the similar figures is equal to the square, right, of the corresponding side. So remember, you can say side over side squared. So if I do 4 over 3 or 5 over 3 squared equals the area of the big one, the 5 I put on top. So the big one has an area of 25. I'm looking for the area of the smaller one, x. Let's solve that. 5 over 3 squared. Well, 5 squared is 25 over 3 squared is 9 equals 25 over x. You might need to cross multiply. You might not. Some of you can see right off the bat, you should get x equals 9. So that means that the area of the smaller triangle, triangle A prime, B prime, C prime, the area equals 9 millimeters squared. Let's try one or two more. Let's look at this one here, number 2. It says the area of the base of the cone is 25 inches. So this guy is 25 inches area. The height is 10. So this height is 10 inches. That's the side. Find the area of the cross section that is 6 inches from the base. So I want the area of this circle. If it's 6 inches from the base, I need to use, for my side over side squared, I need to use the 4 inches here. So I'm going to set this up as side over side squared. I'm going to do 4 over the whole length, which is 10. So 4 over 10 squared equals, I used the 4 on top in the numerator, so that means I need the smaller circle. Well, I don't know that one's area. I'll call it x over the area of the big one, which is 25. 4 squared is 16 over 10 squared is 100 equals x over 25. Cross multiply. 16 times 25 is 400 equals 100 times x is 100x. Divide by 100. And x equals 4. And we were looking for the area of the cross section. So the area of the cross section is 4 inches squared. Okay? So it's just like when we did dilations. Ooh, this is weird. The following pyramids have equal altitude, so that's the height, and both the bases are equal in area and are coplanar. That's no biggie. Both pyramids' cross sections are also coplanar. If BC here, so where's BC? This is this guy, is 3 square roots of 2, and B prime C prime, this guy here, is 2 square roots of 3. Find the area of TUVWX. Oh wait, and the area of this whole bottom shape, that crazy bottom shape, is area equals 30 units squared. What's the area of the cross section in here? So I'm looking for the area of that cross section. We'll call that x. Well, here's what this says. If the following have the same height and the bases are equal in area, well, if the area of that crazy TUVWXYZ is 30, then I know that the area, I'll do it in light blue, of this big base here has to be the same. So they just threw this in to throw you off. This is 30 units squared. So you don't even need this shape. Okay, so let's set it up. Side over side squared. So I'm going to do 2 square roots of 3 over 3 square roots of 2 squared equals, I put the smaller one on top. I don't know the area of the smaller one. I'll call it x over the area of the big one is 30. Don't be thrown off by that 2 squared to 3 squared. Do it in your calculator, okay, and do the top and bottom separately. So I know 2 square roots of 3 squared is 4 times 3, 12. Over 3 square roots of 2 squared is 9 times 2, which is 18, equals x over 30. So just do it one at a time. Do parentheses, 2 square roots of 3, close your parentheses and square it, and you'll see it's 12. Do 3, and again, put parentheses around it, 3 square roots of 2, square that, and you get 18. Now I just cross multiply. I get 18x equals 12 times 30 is 360. Divide by 18. Oops. 20, right? I'm losing it. X equals 20. That's the area of the smaller one. So it's 20 units squared. Okay. I know there was a lot of definitions, guys, and a lot of stuff thrown in here. I typically do that in like 3 or 4 days, but I thought it was important for you to know all of those, the cross sections. I'm not going to go back and throw in that other video. You can watch the link about slicing and rotating 2D stuff. But again, the rest of it's for you. Make sure you're doing the homework. Turn it in complete, guys. You get a +5 for completion. Join the Google Meets. I only have 2 left this Friday and then 1 next week. So 3 lessons left after today, as well as 1 Google form. All right. See you soon.